All right, so if we were going to talk about slope fields, the first thing that you need to know is that a slope field is just a drawing that represents all the possible solutions to a differential equation. And a differential equation is just going to be an equation that we're using to represent the derivative of a function. Something you've already seen where we have x and y in our equation. They label it by saying dy dx equals in the beginning, so our key notation that we'll be looking for is our dy dx equals. That'll tell us that we're working with a differential equation. If I want to draw a slope field, the first thing I should review is kind of what slopes of lines generally look like. If I had a line like this, I have a slope of 1. If I have a line that's completely flat, I have a slope of 0. If I have a vertical line, that's a slope that's undefined. If I have a slope that's going down, and let's say I'll make it a little more steep than the first one I drew, I would say this is a slope of about -2 because it's steeper. Remember, as numbers get farther away from 0, the slope is going to get steeper. As they get closer to 0, the slope will get more and more flat. So farther from 0 equals steeper line. Now, those are things we're going to need to know, because what's going to happen with a slope field is they're going to give us an equation and they're going to ask us to actually draw a picture of all the slopes that represent the equation. So I can give you something, for example, we could have dy dx equals x, and they can ask us to draw the slope field. Normally, if they are asking us to draw the slope field, they'll also give us specific points to draw it at. So they might say, like, draw it at 0, 0. Let's go to 1, 0. Let's go to 2, 0. And then we'll also do 0, 1, 1, 1, and 2, 1. Those will be the 6 points that we're going to draw our slope field at. So in order to do that, I always like to start with 0, 0, because that's the easiest to plug in. And in this situation, my equation that I'm working with only has an x value. So I only care about the x values in my coordinates, because that's all that I'm plugging into my equation. So when I plug in my x value of 0 into my equation, just x, my x gets replaced with a 0, and now I have a slope of 0. So I go over to my point 0, 0, and I draw a line with a slope of 0. A little tiny one, because I don't want to cross over into where the other points are going to be. I just want a little line that tells me the slope at that point is 0. So I'm going to start with my next point. Now I'm going to go to 0, 1, and there's no right order. You can pick whichever point you want to go to next. It doesn't matter, as long as you eventually test them all and draw a line for all of them. I just normally work from left to right to stay organized and kind of make sure that I'm hitting every point that I need to. So then I notice again my x value in this point is still 0. So when I plug it in, I'm still going to get 0, which means that when I go over here and draw my line, it's still completely flat. Because there's no x value, or there's no y value in my original equation, that's going to happen no matter where I am. Everything will be the same up and down, because when my y value changes, it's not going to affect my equation. And if I'm looking vertically, my x value will be the same for all of them. So when I move to my next point, which is 1, 0, now I'm going to plug in my 1, and I'm going to have a slope of 1, which is like a perfect 45-degree angle going through there. I know when I go to my next point, 1, 1, I should get the same slope I just got because I'm moving vertically. I'm not changing my x value, and I do. And then my last points I'm going to try are 2, 0, which gives me a slope of 2. And I just want to make sure that when I draw my slope of 2, it's noticeably steeper than my slope of 1. They're not looking so much for it to be super accurate. They're looking to be able to tell that the slope of 2 is steeper than the slope of 1, that you know that. So then I have 2, 1 is my last point, which gives me a slope of 2. I also know that slopes that are the same are parallel, so I want to make sure that when I'm drawing slopes that they're of the same value, that they look like parallel lines. And that's all I need to do. Now I'm done. This is my final solution. This is my final slope field. Oops. And by drawing those little dashed lines, I have completed the problem.